Good morning, one and all. Myself, Dr. Balaji Maram, professor working in SR University, Varangal, Telangana, India. Uh, in previous class, we have discussed about some fundamental topics related to the Linux distributions, kernel space, user space, etc. Today, we will discuss about some fundamental commands in Linux operating system, as well as we will discuss about the file system concept. These are the basic tools for utilizing the command line means interface CLI to communicate with the operating system or Linux commands. These are the common Linux commands. LS, it simply lists the content of directories. Means it gives files and directories. Directories means like subdirectories in the from the current directory. And the second one is CD. It changes the current directory. Suppose whenever we want to go to the parent directory, or whenever we want to go to child directory, whatever it may be, whenever we want to move from current location to another directory, so definitely the CD command is very useful. Next one is PWD. Means sometimes there is a need to check where we are. Means what is the path of the present directory. Means we are in which directory. So in such scenario, definitely pwd command is very useful. It simply displays the path of the current directory. Next one is cp. Is sometimes there is a need to copy the content of one file to another file. So in such scenario, the cp command is very useful. That is like copy. Cp command name is cp. Means it copies the content from source file to destination file. Next one is move. Mv. Mv. It means move. It simply copies the content from source file to destination file, and it deletes the source file. So that is the importance of MV. Which comparatively CP, MV is entirely different. Because in the case of CB, you can find source and destination files successfully. But in the case of MV, you can find only destination file. You cannot find source file after completion of the MV command. Next one is rm, means remove, delete. So whenever you want to remove a file from the directory, you need to give the path and name of the file. That is through rm command you can remove the file. Next one, free. It shows the memory usage. Okay, suppose some memory space is allocated to the Linux operating system. So in that scenario, the Linux operating system occupies some space. And what about remaining space? How much free space is there like that? Okay, DF, disk fragment. Uh, that is, it checks disk space usage. Means suppose there is a disk, it checks how much of space is used already. Next top, monitors running process. Means already we have discussed, when there is a program under execution, it is called a process. Like that, you can find so many process under execution, under the control of the operating system. So in such scenario, whenever you want to monitor how many running processes are available at this instant, you can check top. Similarly, you can find some set of the networking commands, that is like netstat, ifconfig, and ping. These things are used to troubleshooting purpose when the data is under communication. Linux file system. So here, each and every file and directory, everything is treated as a file only. That is the main difference between the Windows and Linux. In Windows, you can find some set of files are there, some set of directories, subdirectories, and so on. But here, everything is treated as a means one file only. Here, Linux follows a single hierarchical directory structure starting from the root directory. So, it is like a directory structure. The directory contains some subdirectories and so on. We will see the picture. Here, the Linux operating system starts with the root directory, that is like a slash. Here, everything is treated as a file, including hardware devices. It is case sensitive file and directory names. It is case sensitive. Whenever you want to give file name or whenever you want to give directory name, it is like a case sensitive. Next, it is a hierarchical tree structure. It is like a tree. It is looking like tree only, but it contains root, means leaves, and so on, and it supports multiple file systems. Means it supports ext4, xfs, btrfs, etc. Different file systems are there under the control of the Linux operating system, and a strong permissions and security model. So it provides a strong means permission model and security model. Whenever any person wants to access uh, the file or directory, definitely they should have the proper permissions. Otherwise, they can't access any file or directory. So here, the root directory is the topmost directory in the Linux. All other files and directories originate from this root directory only, that is slash. So here, these are the different types of subdirectories under the control of the root directory. First one is slash bin. It is essential user command binaries. Means whatever user commands are there, those commands under the control of the slash bin only. Essential user command binaries. ls, cp, mv, cat, etc. Second one is sbin. Means system administration binaries. Means some set of commands are related to the system, means operating system. So those are like mount command is there, reboot command is there, unmount command is there, that is like umount. So those things comes under sbin only. Next one, etc, means that is like configuration files for system and services. Means all configuration files for system and services are under the control of slash etc only. Next, slash home. User home directories. May suppose some set of users are there. Every user has their own directory. That is, means such directories are under the control of the slash home subdirectory only. Next, root. Home directory of root administrator, means that is like root. He is like a super user of the Linux operating system. And USR, user programs, libraries, documentation, everything is under the control of slash USR only. And slash var, variable data like logs, mail, spool files, etc. Next, slash tmp, temporary files. Means the temporary files are created when the process is under execution, those things. So in such scenario, these temporary files should be deleted after the reboot only. Such files are under the control of slash tmp. Next, slash dev, device files, means like device drivers, means hard disks, USB, printers, scanners, means webcam, etc. Those things are comes under .dev. Such device driver softwares are under the control of means slash dev only. Next one, slash proc. So here, virtual file system with system and process information. Means virtual file system. That is like it contains system information, different types of process are there, process information, everything under the control of slash proc. Next, slash lib, shared libraries needed for system programs, and slash mnt, temporary mount points for file system, and slash media, mount point for removable media, that is like USB, CD. Those things comes under media. This is the picture of a means directory structure. Here it is, means root, slash is root directory, Under slash you can find different directories, boot, etc, proc, dev, home, root, where. Under usr you can find two more, that is bin and sbin. Next, run, tmp, mnt, opt, media, etc. These are like Linux file system file types. Okay, because already we have discussed, everything is treated as a file only. It could be file, or it could be directory, or it could be some other. Everything is a file. Now, what are the different types of file types are there under Linux? First one is regular file. Suppose there is a text file, image file, executable file. So all these things comes under a regular file. That is like a slash, means hyphen. So hyphen means it is like a regular file. Directory means when there is a directory, subdirectory, whatever it may be, it is comes under directory only, and its means character is D. Next one is symbolic link, means shortcut to another file. Is usually we will discuss about those symbolic links and so on, and its character is L. Next, character device, that is like C. Here it is keyboard, mouse, these things comes under character devices. Next, block device. Block device, that is like hard disk, USB, these things comes under block device, that is its character is B. And here client server model or interface communication, all these things comes under sockets and FIFO only. FIFO means that is first in first out, it is like a pipe. And the second one is socket, it is like process to process communication, it is like a client server application. So all these things comes under socket and FIFO only. So here socket its character is S, and FIFO its character is P. P means like pipe. Here, what are the different types of permissions are available under the Linux operating system? So here, every file has 10 bits, 1 bit for the first bit for file type, and remaining 9 bits for the permissions only. So here, the 9 bits are divided into three parts: 3 bits, 3 bits, 3 bits. First 3 bits for owner, next 3 bits for group, next 3 bits for others. So here, what is a owner? Owner means who has created that file, that person is owner of that file. Is it okay? And the second one is group. Group means suppose we have suppose myself is the owner, I have some friends, I would like to share the file with my friends only, that is like group. So for that group, what type of permissions I would like to give, we need to mention under group. Others, suppose myself and group, two are over, the remaining are comes under others only, means not my known persons, some others. So others, what type of permission I should give? So those things I have to mention under others group. Okay. So owner has 3 bits read, write, execute. Group has 3 bits read, write, execute, and others has 3 bits read, write, execute. And first bit for file type, second for owner 3 bits, next for group 3 bits, next for others 3 bits. So total 10 bits which belongs to a file permissions concept. So here, whatever you want to give, you can mention here. Suppose owner, he should have 3 means permission read, write, execute. Group, suppose I would like to give group permissions like read and execute only, I need to mention read hyphen x. Okay. For others, I would like to give permission like read only, so I should mention read hyphen. Okay. So these things comes under the file permissions concept. Okay. So that is your wish. In what way you want to give permission, you can give the permission. Next, inodes and file metadata. So here whenever there is a file or directory, everything is treated as a file. Already we have discussed. Here, the important point is every file in Linux is represented by an inode. It okay? So here inode, that is one type of concept available in Linux operating system. It should maintain some information about that specific file. It okay? So what type of information it is trying to store in Linux operating system? The first field is file size, which size of the file. Okay, suppose there is a file or directory, it should maintain the size of the file. Second one is owner and group. Already you have observed, three categories are there: owner, group, and others. So here owner, owner means who has created that file, that is owner. And second one is group, that is group means some collection of users, that is like group. So what type of means we need to mention who is owner, who is group. And others means other than this owner and group, remaining comes under others only. Next one is what type of permissions we have given. Just now we have discussed in the previous slide how to give permissions, how to change the permissions, and so on. Okay. So here the point is how to change the permission of a user. Means with the help of chmod command, we can change the permission of a owner, of a group, or others. Okay. So that is like a chmod u plus x means user plus x means when we are adding the execute permission to the user, or o plus x when we want to add execute permission to others. We need to mention chmod u plus x or o plus x or g plus x. Suppose execute permission is there for others. Now I would like to remove that execute permission. So definitely I need to give chmod means o minus x and file name. Okay. So in that way we can manage, we can add permissions and we can remove the permissions. Okay. Next one is a timestamp, means when there is a file, uh, when that file is created, when that file is modified, when that file is accessed, and when that file is accessed by whom, which user. So all these things comes under timestamp, and it saves the name of the file and the date and time with seconds, milliseconds also. It stores the information in the inode. Next, location of data blocks. So here when there is a file, the file is divided into different blocks, and the different blocks are stored in different locations in the memory space. So that is the meaning of location of data blocks. So here suppose the file is divided to 5 blocks, 1 2 3 4 5. So 1 and 2 location is suppose miss some part of the memory location, and 3 is in some other location, and 4 and 5 in some other location. Miss those may be consecutive or random places in the memory location. So those, that information is under the control of location of data blocks. Okay. Next. But now we will discuss about symbolic links. Here, a symbolic link is also called a soft link and symlink. Okay, it is a special type of a file in Linux that acts as a reference or pointer to another file or directory. So here, unlike regular file, means we can find so many files, so many types of files are there. But when there is a file, suppose what is that sample.txt. Sample.txt, it is ordinary file, means it contains some text and so on. But whereas symbolic link is not a regular file, it is a reference to another file or pointer to another file. Actually, it should not have any content of any content, because it is a reference to another data block or pointer to another data block. It okay? Means what are the key characteristics of symbolic links? So here, a pointer based reference. A symbolic link contains the path to the original file rather than the actual data. Suppose, anyway, we will discuss in next slide. When there is a file, and when the symbolic link points to the file, it means the symbolic link contains the path of the file, path of the data only. It should not contain the actual data. If the original file is deleted or moved, the symbolic link becomes broken. That broken link is called dangling link, okay, or dangling pointer. So that is the main limitation in symbolic link. Actually, it simply depends on other file. Okay, it is not like independent. Okay, so when the original data is moved or removed, automatically this pointer or this reference will become null. Means that is called the dangling link. Second point, can span file systems. Unlike hard links, symbolic links can point to files located in different file systems or partitions. Okay? With some, suppose the hard disk has some partitions, one partition to another, it can point. Okay? That is the main advantage from the symbolic link. Next, can link directories also. Symbolic links can link to both files and directories. That is the main advantage from symbolic link. Okay. So this is the picture. Miss right side we will discuss later. First left side. So here left side, the data is available in hard disk, and when there is a file, that file is called original file. And when we try to create one symbolic link, we can create the symbolic link, and the symbolic link simply points to the original file only, because the symbolic link don't know the location of the original data. Okay, the original file only knows about original data. The symbolic link don't know about the location of the original data, because the symbolic link simply depends on, blindly depends on original file. So wherever original file points to the data, uh, uh, that is known to original file only. That is not known to the soft link. Okay, that is about soft link. So in this scenario, suppose the data is removed from left figure. When the data is removed, so the data is removed means there is no original file. Means the original file don't know the data file, the data location of the data. In such scenario, the soft link points to original file, but actually there is no original file. In such scenario, that link is called dangling link. Dangling link. Next, how to create a symbolic link? So here the command is like ln -s means soft link, target file means where, that is like in previous figure original file, and a link name means you can give some name of the link. Here some example is there, ln -s /home /user /project /data txt. That is location of the file. Now what about the link name, that is shortcut.txt. So here shortcut.txt is one file. That file points to the data.txt. Data.txt points to the original data which is available in the hard disk. Okay. So it simply creates a symbolic link named shortcut points to the data.txt. Here, how to check those symbolic links? Just with the command like ls-l, automatically it displays the list of the full details of the file. So you can check it. It starts with L. L means it is like symbolic link. L RWX, 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 and some other details are available in the screen. You can check it. Okay. Next, hard links. Okay, soft links just now we have discussed. Now hard link. Hard link in Linux is a direct reference to the actual data. It does not depends on the original file. It simply points to the original data itself. Okay, so that is the main difference between symbolic and hard links. A hard link does not point to the file name, but instead refers directly to the same physical data on the disk. As a result, all hard links to a file are treated equally by the system. Means suppose some 10 hard links are there. So all 10 hard links are points to the same data itself. Right, okay. What are the key characteristics of hard links? So same inode number. All hard links share the same inode number because when there is a data, the inode number is created for that specific file and it points to the inode only. Right, okay. And no original or copy concept. There is no original file. Every hard link is a like original file. And persistence after deletion. Suppose in this picture, suppose earlier you have observed one image. That image is like uh, means like original file points to data and hard link 1 points to the same data, hard link 2 points to the same data, hard link 3 points to the same data. Every hard link and original file points to the same data only. In this scenario, suppose original file is deleted, it will not affect the remaining hard links because hard links knows very well where the data is available. So in such scenario, we cannot find the concept like a dangling link, okay, a dangling pointer, because no hard link is depends on another. Directly it points to the original data. So that is the main, that is nothing but persistence after deletion. So here you can check the picture. Hard links, that is FOO and BAR. Means both are points to the inode number 42. The inode number contains its number is 42. Owners are 2, groups are 2, hard links are 2, permissions read, write, execute, read, write hyphen, read hyphen hyphen. Is pointed to blocks. Earlier, I told you know blocks. Suppose some 5 blocks are there. Those five blocks are at block 1, block 2, block 12, block 24, and block 15. So there is no condition for consecutive blocks. If consecutive blocks are available, it allocates the consecutive blocks only. Otherwise, randomly it allocates some space to the blocks of the file. So in this scenario, you need to check means when there is a hard link is created, that hard link simply points to the inode. Means directly or indirectly, it simply points to the data directly. Means it does not depends on the original file. So that is the main difference between soft link and hard link. Next, how to create a hard link? The example is like ln report.txt, report backup.txt. So here both files now points to the same data on the disk. Now how to check such hard links? ls-li, okay? Then automatically it gives some output. In that output you can check 2048. 2048 means that is like inode number of the of those files. Okay, inode number. So the identical inode number confirms both are hard links only. Okay, so that is the indication some original file is there and some hard link is there. That hard link and original file points to the same inode number. It indicates both are like hard links. Next one, the differences between hard link and symbolic link. First one points to, in the case of hard link inode, in the case of symbolic link file path. Okay. Second one, can link directories. In the case of hard link, means there is no directory. Symbolic link, it supports both files and directories. Means cross file system. In the case of hard links, it will not allow such links, but in the case of symbolic link, it allows means both. Survives original deletion. In hard link, survival is there, but in symbolic link, there is no survival. It creates some dangering pointer. Uses extra disk space. It is in the case of a symbolic link, that is like minimal. Okay. So this is about the soft link and hard link. Thank you very much.